Hi everyone, I am Dr. Padma, Associate Professor in the Department of Computer Science and Engineering. Today we are going to discuss about the subject data structures. In the data structures, organization of data and the management of data, that is done by the subject data structures. In the data structure, we have two basic classifications. They are linear data structures and non-linear data structures. Now we are going to see about one kind of linear data structure that is known as stack. Similarly, we are having many linear data structures: stack, linked list, array, etc. So now, what is meant by stack? So stack is a linear data structure which follows last in first principle. We can explain this through some example. That is, if you are having in our dining table, we have our hot pack. In the hot pack, we are going to put dosas. So we are going to stack dosas, which is stacked first will be served at last. So that is the simple example for stack. So here we can say the insertion and deletions are happen at the same end. That is known as top of the stack. The insertion and deletion are happen at the top of the stack. So for example, other than that, pile of coin, stack of books, bangles in the hand, these are the some example for stack operation. So here we have some clear explanation about the stack. Here we are having data elements A, B and C. So here this one is known as top. We can implement this stack by two representations, that is by arrays or by linked list. So while we are storing these elements, the element which is inserted first will be deleted at last. So we have to push the elements into the stack at the top, and also we have to pop the element at the top. So we have many operations in the stack. First, we will see push operation. Push means insertion of data elements into the stack. So two fundamental operations are performed at the stack. First one is push operation. Is the process of inserting a new element into the stack. So for every push operation, we have to check three things. That is, whether the stack is full or not. Means if the stack is full, we cannot perform the insertion operation. That is why we have to check the stack. If the stack is full, we cannot perform. So this can be achieved by some function. It is known as is full of stack. Similarly, while we are inserting an item, we have to increment it to 1. So that is why the top of the stack has to be incremented every time while we are inserting a data item. So insert the element at the top of the stack. So these three things should be followed while we are performing our push operation. Next operation is pop operation. So similarly, we are going to perform deletion of a data item. So the deletion operation also performed on the top of the stack. So here also we have to check whether the stack is empty or not. If the stack is empty, means we have no element to delete. So that is why we have to check whether the stack is empty or not through some function. So it is simply known as underflow. So second, we have to pop the top element. That is, if you are imagine that the element is x, then we have to remove it from the stack. So after popping the element, we have to decrement the top of the stack by 1. So this is the operation performed on pop. So other two conditions while we are inserting and deleting an item, we have to follow stack overflow and stack underflow. Stack overflow means if the stack is full, we cannot perform any further insertion. So if the stack is underflow, means there is no data item, so we cannot delete any item from the stack. So the stack can be implemented in by two ways: array implementation or linked list implementation. Array implementation, each stack is associated with a top pointer. So for empty stack, first we have to initialize the top value as -1. Stack is declared with its maximum size. Because stack is implemented in array, means we are performing the operation in static. That is, we have to fix the size of the array. So that is why we are using here array. The array declaration of stack will be, we have to mention the size of the array, or we can say like this. So in the stack implementation, if it is implemented in array, we have to define the size of the array. Some operation, we have to first take empty operation. So initially the stack is empty. We have to, it is necessary to check whether the empty is stack before deleting an item. And similarly, we have to check whether the stack is full while inserting an item. So here we are having the routine to check the stack is empty or not. So here the is empty of stack will give top. If the top is equal to -1, means the stack is empty. Similarly, to identify whether the stack is full, we have to check whether the top pointer is located at the top. So routine to check whether the stack is full means we have to insert the item at the top of the stack. If the top size is equal to the array size, means we cannot insert further item, so that we cannot perform the stack operation. So that is mentioned here. So here we are checking whether the top is equal to array size. So that mentions the array is full. So here we are performing the push operation. So before inserting an element, we have to verify whether the stack is full, and we have to perform the stack operation then. So this is the routine to push an item into the stack. Here we are having a stack which is empty. In this stack, here this one is represented as the top of the stack. So if you are inserting an element, that item will be inserted at the top pointer. So which is 5. This here the 5 is inserted first. Similarly, if you want to add an item, first item means the 5 will go, next item will be inserted here. So pop operation, while performing the pop operation, we have to verify whether the stack is empty or not. If it is empty, we cannot perform the operation. Here the stack is full. If you want to pop an item, means the item which is presented at the top will be deleted first. So 50 will be deleted. So similarly, we can perform further operations. Similarly, we can return the top of the data item. So this function shows how to return the top element through the program. So here, if top is equal to -1, means the stack is empty. Else we can return the top value. So if it is not empty, it will return the top element to the as the output. So there are many applications stack. Here we can say implementation of function calls, maintaining the undo list of operations. While performing some operations, we can undo some operation, means which actions performed last will be deleted first. So similarly, we can perform maintaining the undo list of conversion of number bases and checking the nesting parentheses and evaluation of expression, means converting infix to prefix expressions. Like that evaluation can be performed using applications. So here we are at the end of the topic, that is summary of the stack operations. Stack is a collection of data items that can be accessed only at the top of the stack, and a stack is called as LIFO data structure, that is lost in first or data structure. There are many operations are performed. Basic operations are push and pop, that is insertion and deletion of data items are performed on the top of the stack. So stack can be implemented by different data structures, that is arrays and linked list. So stacks are used in many ways. For example, evaluation of expressions. Thank you.